Okay guys, so now we want to see about angle between two vectors. So just a quick revision on what we have learned before. Okay, so we have learned about dot product, where we can find the dot product of vector u and v by using the formula component u1 times with component v1 plus with component u2 times with the component v2 plus with all the component until you have the component of un times with the component of Vn. So this one is how we find the dot product. Then by using the dot product formula, we can find the cosine of the angle phi, where phi is the angle in between of two vectors. Okay, where the formula is the dot product of vector u and v divided by the magnitude of vector u multiply with the magnitude of vector v. Okay, then we also have seen about when the two vectors is said to be parallel. Okay, when two vectors is said to be parallel if and only if the value of phi is either 0 or 180 degree. Okay, and the vector u and v also is said to be parallel is there is a scalar alpha that connect the vector u and vector v. Okay, there is any scalar, any constant alpha that can connect both vector u and vector v. Therefore, we said that vector u and v is parallel. And then one more for parallel vector is you will have it will be said that two vector is parallel when the cosine atau or the cos phi. Okay, the cos phi give you the value of positive or negative 1, because the value of positive or negative 1 when you transform, bila you pindahkan cos ni pergi sebelah, you akan dapat the value of phi is either 0 or 180 degree. Okay, so bila you dapat cos phi sama ada positive 1 or negative 1, automatic you know that both are parallel vector. Okay, and for perpendicular vector, iaitu vector yang sertentang, okay, perpendicular, or we also said as orthogonal vector. Okay, the value of phi will be equal to 90 degree. Okay, when you have a value of phi equal to 90 degree means that the vector u and v are perpendicular. And one more is when you find the dot product of u and v, you will get the dot product is equal to 0. So this is the sign that both vectors are perpendicular, because when the dot product give you equal to 0, okay, you will have cos phi equal to 0. Therefore, phi automatically will become 90 degree. Okay, because cosine 0 is equal to 90. Therefore, these two conditions will give you, will tell you that both vectors u and v are perpendicular or orthogonal. So that one is what we have learned before. Now we want to see about the angle between two vector, which is the angle between two vector is defined as phi before this. Okay, so we will see a few types of value for angle between two vector. Okay, the first thing is the angle phi in radian between two vectors is phi greater than 0 or less than pi, or pi is in radian, where in degree is equal to 0, is equal to 0, okay, less than 180 degree. Okay, means that from here to here. Okay, so nilai phi akan start daripada 0 sampai ke 180 dalam degree, ataupun 0 sehingga pi dalam radian. 3.142 itu adalah nilai phi. Okay, so nilai phi is acute if and only if the dot product is greater than 0. Okay, so we will have the value of phi. Okay, angle ni kita panggil dia sebagai acute angle. Acute angle kalau dot product of u and v greater than 0. Okay, this one is acute angle. Okay, so nak check sama ada phi kita ni acute angle ke tak, kita cari dot product of U and V. So kalau kita dapat dia greater than 0 means that our phi is acute angle. Acute angle means it's less than 90. Okay, then phi is obtuse. Okay, phi is obtuse if and only if the dot product of U and V is less than 0. Okay, so phi is obtuse kalau dot product of U and V less than 0. Obtuse means it's greater than 90 but it's less than 180. Okay, dia besar daripada 90 tetapi dia kurang daripada 180. Kalau acute, dia kurang daripada 90. Okay, 90 macam ni. So acute kurang daripada 90. Kalau obtuse besar daripada 90, kurang daripada 180. Okay, so macam ni kita nak tahu kita punya angle tu obtuse ke acute, kita cari dot product. Kalau dot product greater than 0 maksudnya acute angle. Kalau dot product less than 0 maksudnya obtuse angle. Dan kalau dot product equal to 0 maksudnya right angle, which is 90 degree. Okay. Okay, means that if you have a perpendicular vector where you have this vector like this, the one vector like this, U, okay, and then you have the V vector like this, okay, so you will have the right angle triangle, so the dot product will be equal to 0. Okay, this one we have seen before. This one is the property of perpendicular vector. Okay, because the perpendicular vector will give you the phi, the angle equal to 90 degree. Okay, so this one is when the phi is equal to 0 means there is no angle between these two vector. If you see, this is the first vector and this is the second vector. So this vector is parallel in the same direction like this. So this is when phi is equal to 0, while this one is when phi is equal to pi, where you have the 180 degree of pi phi. Okay, the value of angle is 180 because if you see the direction of the angle, even though it's parallel but it's the different or the opposite direction. Okay, so the phi is equal to pi. So we have three types of phi. If we have phi greater than 0, if we have the dot product U and V greater than 0, okay, dot product U and V, okay, if greater than 0 means we have the acute angle, where the acute angle is less than 90 angle. Then if we have the dot product less than 0, we have obtuse angle, where obtuse angle is greater than 90 but less than 180. And if we have the dot product equal to 0 means we have the right angle triangle, which is 90 degree. Okay, so next we go to the definition of projection vector. Let the vector U and vector B be non-zero vector, means vector U and V can be defined with some can be defined as a vector. The vector projection of U on V is a vector denoted by project of U on V. Okay, you see U on V. So this one is the projection of U on V. V is the subscript here. Okay, so how can we calculate the projection of vector U on V? It will be the dot product of vector U and V multiplied by the magnitude of vector V to the power of 2 and multiply with the vector V itself. So this one is the formula to find the projection of vector U on V. Okay, and we also have the scalar projection. If this one is a vector projection, okay, we also have the scalar projection of U on V, where the formula is given by the dot product of U and V divided by the magnitude of U, the magnitude of vector V. If the projection of vector, okay, the projection of vector U on V, the formula is dot product of U and V divided by the magnitude of V to the power of 2 multiplied by the vector of V. Okay, but the scalar projection, the formula is the vector U and V, the dot product of vector U and V divided by the magnitude of V. Okay, so let's say example here. Let's say you have the vector U equal to 2i plus 3j and vector V equal to I plus j. Calculate the projection of vector U on vector V. Okay, so this one can be read as projection of vector U on vector V. Okay, so the formula to find the projection of vector U on vector V is the dot product of vector u and v divided by the magnitude of vector v to the power of 2 multiplied by vector v. Okay, so we have now vector u. We want to find the dot product of vector u and v. Okay, we have now the vector u 2i plus 3j. So dot product with the vector vi plus j. So we know how to do a dot product where we take the 2 multiplied by 1. So we have 2 multiplied by 1. Okay, plus with 3 multiplied by 1. So we have 3 multiplied by 1. So we have 2 times 1 is 2, plus with 3 times 1 is 3. And then we find the magnitude of v, where the magnitude of v is x squared plus y squared. So x is 1, y is 1 as well. So we have 1 square plus 1 square. So we have 1 square is 1, 1 square is 1, so 1 plus 1 is 2. So we have set 2. This one is the magnitude of v. Therefore, to find the projection of vector u on v, okay, the formula is the dot product of uv, which is 2 plus 3, 5, over the magnitude of v to the power of 2. So set 2 to the power of 2. Multiply the vector v itself. So the vector v is I plus j. Okay, therefore, you have the set 2 power of 2, the set and the power will be eliminated. So you left only 5 over 2 I plus j. Therefore, we can say that the projection of vector u on vector v is equal to 5 over 2i plus 5 over 2j. Okay, so let's say one more example here. Let vector u equal to 2i minus 3j and vector v equal to I plus j. Calculate the projection of vector u on vector v. Okay, so we have to calculate the projection of vector u on vector v. So the formula to calculate the projection of vector u on vector v will be the dot product of u and v divided by the magnitude of v to the power of 2 times with the vector v. Okay, so now we need to find the dot product first, u dot product with v first. So our u is 2i minus 3j, dot product with the I plus j. Okay, so 2 multiplied by 1 is 2 multiplied by 1, plus with negative 3 multiplied by 1. Okay, so we have 2 times 1 is 2, negative 3 times 1 is negative 3. So we have 2 minus 3 is equal to negative 1. Therefore, the dot product is equal to negative 1. So now we want to find the magnitude of v, where the magnitude of v can be found by the square root of x squared plus y squared. So x is 1, y is 1. So we have 1 square plus 1 square is equal to square root of 2. So we putting the value inside the formula. So to find the projection of vector u on v, the formula is the dot product of uv, which is negative 1, divided by the magnitude of v to the power of 2. So we have set 2 power of 2 and v itself is I plus j. Okay, so set 2 power of 2, set will be eliminated. So we only left with negative 1 over 2 I plus j. Therefore, you have the final answer projection of vector u on v is equal to negative 1 over 2i minus 1 over 2j. Okay, so this is how to find the projection of vector u on v.